Good morning, students. Today's topic, which we are going to read in physics, is lenses. So, we are going to start now. Concentrate yourself. Lenses are very useful. In fact, you are using the lens in your eye to focus on these words now. Kinds of the lenses. A lens which is thicker at the center, this one, then at the edges is called a convex lens. So this is convex lens. A lens which is thinner at its center, this one, is called a concave lens. So this is the concave lens. A convex lens is a converging lens. Parallel rays of the light are refracted through the principal focus of a convex lens. So this is the figure. Parallel rays of the light are refracted through the principal focus of the convex lens. Here is the focal length. A concave lens is a diverging lens. Parallel rays are diverged so that they appears to come from the principal focus of a concave lens. Objects are always look smaller through the concave lens. And here is the figure. A fat lens is a strong lens with a short focal length. A thin lens is a weak lens with a long focal length. Ray diagram for convex lenses. To draw accurate ray diagrams, you can use two constructions. Construction number one. Parallel rays of the light are refracted through the principal focus. It is also useful to mark points called 2f at twice the distance. So, parallel rays of the light are refracted through the principal focus. Here is the principal focus, so it will be refracted through the principal focus. Construction 2. Rays of the light passing through the center of the lens. Here is the center of the lens. If light rays passing through the center of the lens travel straight on, will pass straight on. The images depend on where the object is placed. Distant object outside 2f. So if the object is placed outside 2f, image between f and 2f. So its image will be formed between f and 2f. Inverted, diminished, and real one. Used in a camera in your eye at this moment. So the method to draw the diagram is same. The parallel ray will pass through the focal point and the ray that passing through the center of the lens will pass through straight. Next is object between f and 2f. So if the object is placed between f and 2f, image will be formed outside 2f. Image will be inverted, diminished, and real one. The method is same. The parallel ray will be refracted through the focal point. The ray passing through the center of the lens will pass through straight. And here is the crossing point of the two rays. And here will be the image. This kind of the lens is used in slide projectors, film projectors. So this is the application in these two kinds of the projectors. Next is, if the object is placed between f and the lens. So this is the f and this is the lens, and if the object is placed between them, image appears to be the same side of the lens. So image will be formed on the same side, upright, magnified, and virtual. So the method is same. The parallel ray will pass straight, will strike on the lens and will be joined to the upper point of the eye. The light ray passing through the center of the lens will go through straight and will attach to the lower point of the lens. These lines will be extended, and from here this will be broken line but will be straight one, and here will be the image that will be upright, magnified, and virtual. Used in magnifying glass, eye lens in telescope, spectacles for long sight. So student, this was the lecture of lens, an important one. Read this lecture again and make your notes. Thank you so much.